Hello, everybody. I'm glad that you can join us, and I'm here with Adam Wright of Measurable Energy. I'll let him do his own proper intro. We're here to do from cost chaos to control, break the set and forget cycle in energy management. That sounds very highfalutin, but we're actually going to get down to some really sort of simple things. So we did talk about beer fridges that paid for themselves very quickly, and I'm going to let Adam do all of that. I don't want to steal any of his thunder today. So a little bit of housekeeping. If you get the chance, please rate this webinar as you go along or at the end, and we will take questions as and when we get them. So please feel free to send questions. We're very much in a Q&A mode today. We've got a few slides, but not loads. It's going to be really myself and Adam discussing what they've been doing, what Measurable Energy has been able to achieve, and really look at how you can do something quite simple. And you know I'm a very simple person. Yes, you're supposed to all say no and not yes to that. But yes, that's what we're here for. So, Adam, why don't you do a very quick intro for yourself, if that's okay?
Yeah, sure. Thanks. Yeah, great to be here today, guys. So my name's Adam Wright. I'm the product director at Measurable Energy. At Measurable Energy, we use our very own intelligent sockets to learn all of the energy use and occupancy of that building based on that energy use, and then automatically turn off all of the appliances that are plugged into those sockets that are wasting energy. And we're going to dive into a couple of topics today about this.
Okay, that sounds really, really simple for an idiot like me. So so we were discussing before we came on air about, I was just looking at my house. So actually, why don't we talk about the 60s and the 70s and what it was like for people, and then a little quick history lesson. How about that, Adam? Would that be a good way to start?
Yeah, sure. And I'll kind of just show you this maybe to give some context here. So people, might often be thinking, why do we go after, plug sockets, power sockets, traditionally called small power, and there's that connotation with the name small, that it is, small stuff. But that name came up, in the 60s when we plugged in, far less appliances than we're plugging in modern days. And
I can almost remember the 60s. I should. But my parents told me there used to be a TV and a toaster and a kettle. And that's pretty much it. But if you actually think about what we have in our houses and then what we have in offices now, it's a lot more, isn't it? We're just plugged in so much.
Absolutely. Look, half of our appliances now have a battery in them. There's something charging, all the time. There's way more smart connected devices than we've ever had before. And what we've seen through our own research, our own installs, and third-party research, and even our customers, is that up to 40% of a building's energy use comes from all of those appliances that are plugged into the plug sockets. And within the sort of like hybrid working environment that we're in now, up to half of that is just wasted energy, things that are plugged in, charging, on standby, even active, when people just aren't in those buildings. And the straight up, you can see, weekends, overnight periods in a week, weekdays, but then also just those patterns that happen within a building on, in this department's in for this day, but not in for this day. All of those periods add up to that kind of wasted energy.
So you say, okay, I'm working from home today, as you can see, probably. And I'll probably go for lunch. I'll spend 30 minutes, 45 minutes, but I'll leave my laptop plugged in. So you're saying that really that's just wasting energy.
Yeah. So anything that's sat there that it has a standby mode or has a low power energy mode that's plugged in on there is always using some form of trickle energy. Some appliances it's larger and it can be significant, and others it is smaller, but it all adds up together and it all creates this sort of adds to this bucket of energy that is this 50% of small plug load waste.
So I know there are studies around this, but it sounds like you've already done this with clients of yours where they've probably gone, no, don't believe any of that. And then actually when you've measured it and shown it, they've gone, oh, wow.
Yeah, and not even that now. Honestly, some of the time we're getting people come to us where we've already done our initial calculations. We've looked at our meter data. We've looked at the data that we've got available to us, and what we can see is that our plug load is accounting for about 40% of our total energy use. We've done, we've gone after our, our lights with LED lighting upgrades, or, on smart sensors and things like that. We've optimized the BMS as much as we can without having to rip the whole thing out and, an upgraded 20-year-old system. This is we've already determined this is our next sort of, quick win, so to speak.
Right. Okay. So, I mean, does this matter to end users? I mean, let's be frank, energy prices are pretty high at the moment, so anything they can save is probably a good thing. What else should they be looking at?
Yeah, I think this is a really good bet, and we should maybe set the scene here.
Oh, it's almost like set that slide up. That's brilliant.
Yeah, I think let's set the scene a little bit. So we're always among the top 5 expensive electricity prices in globally. Us, along with Denmark, Ireland, and Germany, we're always bunged in there. And we know that this volatility is not allowing us to come down in energy prices anytime soon. It's widely regarded that we've got a fairly long-term path to getting back to sort of pre-COVID energy prices. And then that kind of other challenge with it. So we've got this sort of energy prices are high for us, but also there's this whole piece around what are the quick wins, what are the quick things to do. I mentioned it before, absolutely go and get LED lighting done. That's an absolute complete no-brainer. You're going to get into it. In many cases, BMSs can be optimized a little bit more, and there can be relatively low cost upgrades done to BMSs, and you can get more savings. Great, go and do that. But there are also ones that were put in 20, 25 years ago, and you're talking about upgrading, changing all that hardware, everything that's in there. And now that's a costly thing. So, and some of those systems can, those older ones that need those upgrades are very much set and forget. This is the schedule, and, it's not really been looked at for a long time. So if you put these things together and you've got high energy prices, some things that can be done quickly, some things that are costing a lot of money, and maybe energy tech that needs a lot of upgrade that's not as simple to maybe update. And we've got this perfect environment for where we need to find these places that we can save quicker.
And I think you've not put on this slide, but actually anything that you say from an energy perspective is going to bring carbon emissions down, whatever, because. And so therefore, if you're a company that's looking at its net zero position, anything that can bring emissions down is going to be a big thing as well, isn't it? I mean, that's what's driving large companies and also the companies in their supply chains. We've seen it now for the last few years, and I'm sure you have as well.
Yeah, absolutely. That what we're talking about in terms of these savings here are that, we're not having to produce that energy that was being produced to fill that stuff that was getting wasted overnight or weekends in hybrid working patterns, and if you're not producing that, there's that carbon, reduction that you're getting for that, and some of it might be at times when it's lower carbon on the grid, but other times it's at peak time. It's in the middle of a day where we can, you can start getting rid of that, and there's high amounts of carbon reduction from it.
You mentioned BMSs there,
yeah.
And I know you're going to talk about the smart socket at the socket and what you're doing. And in fact, actually, before we go into the BMS thing, why don't you just quickly talk about, what measurable energy can do? Because I think that would be useful, actually, just to set the scene as to, you're talking about, wow, you can make all these savings, but what are you actually doing? And how, and what I like about it is it's actually very simple.
Yeah, sure. Okay. So let's maybe use this one. So, essentially what we're talking about here is some plug sockets, like a double wall socket, an extension lead, a fused connection unit, a fused spur, and it's a faceplate swap of these, or an extension lead getting plugged in. So it's really kind of it's quite a low barrier to being able to get that in. Any electrician can swap a faceplate, and anyone can plug in an extension lead. So it's very simple to get the system in. It comes completely pre-configured. So, we've already liaised with the IT team. We've already gone through the cybersecurity, process, and it comes ready to connect straight away as soon as that gets installed. As soon as it goes in, the data is available then on, in the cloud, and people can see it, and you can start seeing the energy consumption that's coming through and all those appliances that are plugged in. And then within the first 24 hours, the AI element can start identifying those appliances, generating schedules that will control sockets, and then gathering those savings. So in terms of like, barrier to entry and then speed to get going, it's very quick.
Okay, so Adam, let me just get this right. So, yeah, let's just assume we're going to go with the extension lead or the plug-in. So we're not even going to need the electrician. You plug that in, it's all set up so that it's not going to, the IT department aren't going to get upset. You plug in your computer or your kettle or whatever, and then it's not just being a dumb socket; it's actually collecting data about usage, and then that's passing it over to some centralized spot.
Yeah, absolutely.
If you put 10 of those, then you'll be able to identify each one of those plugs as well, will you?
Yeah, and this is and the identification bit is all about context for being able to control things automatically. So let me give this an example of like an office. Okay.
Yeah.
So if you have, say, the extension leads all across the desks, and we have maybe the TV and the AV equipment plugged into a wall socket in the meeting room, and in the kitchen there's the hot water tap and maybe some other kitchen appliances, coffee machine, let's say, a bottle fridge, things like that. The identification then gives the context for those areas without having to go to that building or with the people that are managing that building and ask them everything that's plugged in and then label up all these sockets. So if the system knows that all of that's computers and monitors in this area, and there's very little energy consumption coming from them, it's all standby. We know that there's no one actually actively using energy in that area. But then why is the meeting room TV still on? Why is the hot water tap still boiling hot water?
Yeah.
Why is the coffee machine still on? If the office area has dictated that there is no one there from the energy, these other ancillary bits around it, and that's where the identification really comes in for us in terms of being able to automate those schedules, find those little areas, and that's why I mean it's not just the overnight at weekends. It can be a department that don't come in on a certain day of the week. And they might have a couple of meeting rooms around them that are, regularly used by them, but they're not there.
Okay, I'm getting it now. Okay, so and do you have to do anything with the AI? Does it automatically set it? Oh, do you need to set some, parameters and such like for each installation?
Sure. So it starts getting this data. It looks at all of these kind of like patterns in there, and then it makes these suggestions in terms of what the schedule should be. Now we don't go full blown AI is controlling all of your sockets in your building from day one. There is an element of human interaction there to basically go, are these suggestions sensible for your building? Do they work with you? And regularly it's a yes, these bits do, this one does, this one doesn't. Actually, no, we don't want to turn that off. We need that on for this reason that is outside of the system's knowledge. And then once, so there is an element of that, but then once it's going, it's then the schedules are agreed, and all of the all the reports can then be set up to start sending automatically all these these energy savings, and then after that there's an element of the system continues suggesting more places that it might find it, and we build towards that place where people are happy to just accept the suggestions and keep having these additions in it.
So it's not in full Terminator mode then.
No, it's got any AI system we'll all know, because it's in media in front of us all the time. The best systems have some form of human interaction with it to just vet it and just ensure that it's on the right path and tweak where needed.
Okay, right. So we're going to go back to my BMS question. So you've got a BMS in place. You start to put do these sockets work together with the BMS, or should you actually get rid of the BMS, or should you do something more with the BMS? What sort of it? I know it'll probably be different for various places, but try and give us a feel for that.
Yeah, no, it's a really good question. So look, the vast majority of BMSs, in fact, almost all of them, don't take in granular plug socket data into them. The BMS will have all the HVAC, any other heating or ventilation that's in there, air conditioning, it will have lighting, it might have other plant equipment into it. It is very, very rare to ever see a BMS that is taking in it might take meter data from what's happening on the on the circuits that are on those sockets, but it's very, very unlikely to ever have a smart socket connected up to it. And we don't come in and go, no, you need to immediately get this and integrate it into your BMS, but it can be. So it's not something like we should do this or this. It's something that should be done together. This is bringing all of that kind of plug level energy savings and opportunity and making it visible to the BMS. So we've got relatively simple APIs that can integrate data, from our platform into it. You can see the energy consumption in your BMS if you want to, and you can even schedule control, from the BMS if you wanted to. Though we wouldn't recommend it because we'd lose out on the sort of the AI side of identifying these patterns.
Okay, I've got a question actually. So as I said, thank you very much for sending questions in, everybody. But I've got a question that's sort of relevant at the moment. So this is Alex. Morning, Alex. Good to see you. Well, not see you, but to hear from you. Refer to your previous slide referencing 40% of commercial businesses is plug-in consumption and up to half that can be saved. So we're looking at a potential 20% reduction. My question is, in your experience, what are the biggest factors at the end user side to seeing the benefits, bear with me, long term, as opposed to the initial impact versus old habits dying hard? There's almost 2 or 3 questions in there, but I think you've got it, haven't you, Adam? So yeah, give us an idea of where you see it.
Yeah, no, it's a really good question. Yeah, look, exactly. So 20% reduction is like is basically our kind of starting point. That 40% of small power coming from commercial buildings. There is a range in there. We find commercial buildings that are using a lot more small power than that. Hospitality is a key one. Modular buildings that have a lot of electric heating. Anything where more is electrified, you can that kind of sort of split can go right up. But yes, 20% is a really good place. That's a really good starting place that we go for in terms of the reduction on that building. So right, biggest factors in terms of so this maybe my opinion, or we probably share this at Measurable Energy, I suppose, but our thoughts on this are, whenever you put something in or someone adopts a piece of technology and then they have to do a lot with it. They've got to log in, they've got to do this, they've got to do that, they've got to check on that, they've got to log in to run that report to see that savings. That's where it becomes so much harder to get that piece of technology to stick. Yeah. And our kind of philosophy has all been is we have this dashboard and we have this place that you can log in and see it. But once it's set up and those schedules are saving and those reports are set up to come to you at whatever cadence you want to see them, the idea is you don't need to go in there. You don't need to do anything with this unless you really,
we were talking about breaking the set and forget cycle in energy management, but you're now saying set and forget.
Yeah, well, but it is a forget in terms of logging in, but it's not in terms of what you're getting for your report. So you're constantly getting like, this is how much you saved this month. This is how much you saved this month. This is what your quarter looks like. This is what you've said. So
you can still be proactive in that sense.
Yeah, exactly. And look, and I am simplifying it here as well, because there are other reasons that you might want to log in and do stuff. You might want to look at what anomalies or things that are going on in other places, high energy use that's unexpected. But at its core, having that simplicity of it being able to get it up and going, and knowing that it is then making the changes for you, and you're getting asked, are you happy with this? Are you happy with that? That kind of automation where you're asked a question and it's just a yes or no and then off you go is much easier to embed than someone having to log in constantly.
Yeah, okay. So going back to the benefits for the end user though, let's do you think it's because it's simple and therefore it can be sort of left to its own devices, with you obviously keeping an eye on it from a proactive sort of view? Is that the biggest benefit? Because in effect you can apply your capital or your money to this, and you sort of know it's. I'm not saying it's guaranteed, but you've got a very likely chance of it saving money for you.
Yeah, exactly. And look, there's loads of ways of reducing that risk. We don't expect someone to go and take 10,000 sockets and do their entire estate in one go. Quite often you start with a selection of, it could be a whole building, but it could be floors of a building, depending on the size of it and that kind of stuff, where you've covered a load of appliances that are really are a good representation of what's in your whole portfolio, and then you do that one building or that one area, And then from that, you go, well, we saw, this is exactly where we saw these savings. Maybe here's where we didn't see as much as we thought, but here we saw a lot more. Now you've got that blueprint for, well, if this got scaled out across the whole thing, it is as close to guaranteeing that, there is, that is what the saving is going to be.
So it's a classic. It's do the pilot. You can see the saving right now. Now let's go to, like you said, whether it's a floor or a building or whatever. And it's almost like we're making the savings, so now we can afford to put some more money in to then get more savings.
Yeah.
Okay.
Yeah,
So
exactly.
FDs must love you. Right. Now we're talking about pilots, and so that's for, and actually something to do with implementation. So Kian, thank you very much for sending this question in. Does the hardware use the client's data network to send data, or does it have its own built-in connectivity? And that's a very good question, actually.
Yeah. So we use the Wi-Fi of the building. Sometimes it is a specific IoT network that they've got. Sometimes it's a standalone hidden network that's set up. In some cases, it is the corporate network. It just completely depends on the business, what their IT team is comfortable with. We go through a security process with every IT team that we onboard with.
I was going to say, what are the issues around cyber? I mean, you've only got to look at what's been happening at Marks and Co-op and Jaguar Land Rover. I mean, the fact that someone could hack in and effectively turn off the whole building would be a bit of a scare for me.
Yeah, absolutely. And there's, I always get people to kind of try not to think of these sockets as the kind of ones that you would get in your home. They're nowhere near that in terms of a cybersecurity perspective. They come pre-programmed. There's encryption at almost every single level of this. They're completely air gapped. The sockets don't talk to each other. They only talk to the cloud. They go through. There's only, we can go through firewalls. There's only like a couple of ports that need to be open to go through them. We answer all of these kind of cybersecurity questions. We go into, NHS hospitals. We've been in military manufacturing sites, banks, big corporate networks. Some of them we can go through it quickly. Some of it's a bit of a longer process, but we've generally answered all of the questions and provided all of the security certifications and stuff that they need to get through those.
Okay, I want to come back to hospitality. So you mentioned hospitality, and I'm sure there are a number of different sectors, and we'll come on to those. So I think people can see how very much this could be used in an office setting, and I'm sure from a hospitality. But I've got somebody going beer fridge. So I think we're 20 minutes in. I think we have to do the beer fridge story. So for all those people that came in specifically for the beer fridge, here it is. Beer fridges do mean energy management. I know that sounds weird, but I will let Adam explain.
Okay. Right, here's the beer fridge one. We'll get to it straight away. Right. So we do a fair amount in hospitality, and one of the places where there is, incredibly good payback and makes a lot of sense is within bottle fridges. So we're not talking about any fridges that have food in them. We're not, those are not getting turned off. We're only talking about places that have soft drinks or our alcohol in them. And particularly in businesses where there is a very set time period where they need those on, and generally quite long periods between them where they don't need to. So that can be bars and restaurants and things like that, where they're going to turn off at some point, or they can potentially turn off at some point in the night, come back on the next day. And the fridges are not being opened, so we've got no drastic loss of temperature, and there's a good saving every single night. But there are other things here as well, and this is a fantastic kind of case study that was done through one of our partners with a Park Eat building at Reading University. So this building has got a bar, it's got a big commercial kitchen, it's got quick serve sort of restaurants in it. And it's also got like a sort of almost like a co-working space there as well. They covered the whole building, and one of the very first things that was found was that in the bar there were these 5 bottle fridges, and the 5 bottle fridges were using a very high amount of energy compared to the data sheet that said what it should be using. Now, it was known that they were quite old, but there had never been any monitoring on them from an energy perspective. When we started monitoring it and they saw how high it was, there was there was sort of a kind of a decision straight away that, look, these are really at the end of their life. We should replace these. And there was a projection to say that we thought that maybe we could reduce the energy consumption on these fridges by about 70%, if these fridges got changed. So they bought some great, new, kind of sort of energy efficient bottle fridges, installed them in, plugged them back into our socket, and immediately we saw an 89% reduction in fridge energy use. It accounted for about £12,000 a year of energy savings. And it obviously completely paid for the replacement of the fridges, and also paid for the install of the whole thing in that building. But there was something very, very crucial from it. And I know it's maybe a little bit tricky to see on there, but what you can see on that kind of that snapshot of the hub is that the yellow line is the old fridge. And you can see that we're turning that one off overnight. And every time it comes back on, even though it's never been opened, there's a spike in energy use. It's got old seals. The motor's not great on it anymore. The compressor's not particularly effective. And then it kind of stabilizes, but the energy is kind of all over the place. And then every time it gets turned off, it comes back with this whopping great spike. But you can see that the new energy efficient fridges below are obviously using a lot less energy, but they are completely flat. And when they get turned off, there is no spike in energy because the fridge isn't open. They've got great seals on them. The compressor is in really good condition. It's had good maintenance. So it can also inform that there's, that we can see this pattern change over time. So, if we see these patterns happen again, it can be an indication that those fridges might need, something. They might need to, some maintenance on them, some new seals, things like that.
Okay, so it's interesting. So, they knew they were probably coming to the end, but actually it's like anything. They would have probably fudged it. And by doing this, they actually went, right, here are the numbers. So actually, whatever you say, that just giving the numbers makes a massive difference to people anyway.
This is it. These were plugged in. Like, if you think about where this is plugged in, that socket is not accessible. It's completely behind a fridge. Yeah. It's put in, at the time that the building's, put in, the fridge goes in many times. It's not coming out. There's not, you're not able to get like a spot monitor or something on there. The circuit's got lots of things on it, so you don't really get in the full picture by monitoring that circuit that it's on. So what it meant is that in terms of this one, there was the team had a hunch that there was something that might be interesting to look at there, and then the data allowed them to act quickly on it and then capitalize on that saving really quickly.
Okay, so I got a question actually from Peter. Thank you, Peter. I can see that this will identify the quick wins, and this is a proven case study on that. But I would think that the ongoing savings will be small. So that's interesting. Okay, so I get it, Peter. So. Is the issue is that once you've done maybe the quick wins, the bigger stuff, how can you make sure that you're continuing to get the sort of wins as well?
Yeah, well, look, the real sort of part to this is the whole kind of like scale bit in terms of being able to capture as much as possible. So if I give this building as an example, there are also like grills and various different pieces of kitchen equipment, and there's a projector, and there's big TV screens. There's all sorts of other appliances in here where we didn't necessarily find one of these replace the appliance and get a big win, but the savings from that are because they are just every day, every week, every month, every year. There's just reductions in it, and that's where that kind of sort of keeping the savings coming. So you're absolutely spot on with these bottle fridges. Now that saving has been done on there, the energy savings are not actually that big now on those fridges, but they got all of their payback by getting that in, and now they're just banking savings moving on.
Okay, so I mean that's the other thing, isn't it? Is that you're forgetting that you are getting the savings ongoing as well. So whatever the energy price, even when the energy price say goes down, then you're still getting savings from that. And also what you got to think about is your emissions have gone down as well. You're saving from an emissions point of view. Okay. So Andy asked, will the presentation be available afterwards? I'm assuming it will be.
Yeah, we can make it available. Yeah.
Yeah, lovely. Okay, so let's let's look at some other stuff. So thank you for the beer fridge. I think that was worth waiting for. Is there anything that when people put in something like measurable energy with the sockets, is there stuff that they weren't necessarily expecting to happen? Because obviously it's all well and good. You pick up these things, you go, right, we can swap over the beer fridge. We've made a big saving, or we know that this is where we can turn it off and then we make a saving that way. But what about the stuff that you wouldn't necessarily think about? What sort of stuff are you coming across?
Yeah, so I can feel you going in a direction here, Geoff. Are we moving towards? Are we thinking behavioural change here in buildings?
Well, I think it's interesting because I've always felt that behaviour change sounds like a great thing to do.
Yeah.
And I've been in the energy industry for 15 plus years now. You know that's but for those 15 years, I've always heard about behaviour change, and I always worry that it's just one of those things that people do for 6 months and then they forget about it. So I'd be really intrigued to see if that is something that this helps with, but also, is there anything else that we're missing that maybe you should be pushing out there for people?
Yeah, no, look, we'll I'll tell you what, we'll definitely go into behavior change, because it's such an interesting one, because you're completely spot on. It's always been a buzzword, within energy, in terms of changing people's behavior. We've seen it happen so many times, where people have used all sorts of things, from posters and stuff like that. But before we dive into it, I think we should go into one other, because it is relevant to hospitality and it's relevant to everywhere.
Okay.
So one of the other things that that we sort of kind of realized where we could provide another kind of added value. Now, obviously, it's the energy savings, the carbon reduction. That's our key. That's the thing that we're doing here. That's the thing that why people are buying up our system, why we're getting adoption. But there are a couple of other little bits that can kind of help out with this. And one of those is that we always thought it was absolutely mad that a 13 amp socket, in the UK, can just regularly, take 20 amps, running through it, or 25, and a socket can get overloaded with an extension lead with loads of heating elements, or heating urns or something like that, plugged into it. And basically, the only time when it stops is when there's either damage to the equipment or the plug socket itself from overheating. So one of the things that we looked at is all of the amount of energy that's coming through these sockets, places where we've seen overloaded sockets, where we've seen issues maybe with heaters, or or things like that. And we have built in a safety system in there. So every single socket has it, regardless of whether or not people can see that value to them in their building. But what it does is it allows for sort of sporadic energy spikes, like you would normally see with appliances. So a microwave turns on from the first time, you are likely to get a spike above 13 amps. A heater comes on for the first time, a compressor, all sorts of things regularly do go above 13 amps, and they do it relatively safely and then carry on working normally. But if we see something go drastically above 13 amps and stay there for sustained periods, and I'm talking, 30, 60 seconds, then we've got an automatic cutoff that will trip the socket and turn it off. It's resettable. It can be, people can, can address it. But it's just a safety catch for if something something overloaded has been plugged in, or there's a fault with with a heater or something else that's been plugged in.
Does it work the other way, like a UPS as well? So if there's a slight break, then you've still got power.
Not quite, because the UPS has got obviously a battery in it that's able to then So it means that they don't. If you actually did get a break in the power supply to the socket, it would still lose power.
Yeah. Okay. No, but it's just but I understand why you don't do that. But the safety aspect is okay. So that's effectively built in, whatever. So you're not really paying for that. That's just an added value.
Yeah, that's it. And then, and then within it, we get, we see lots of sockets that, the sockets don't just trip straight away. You don't just you suddenly plug something in and then instantly it starts, hitting this safety service and going. Generally, we see a ramp up to it. So we can also see and report on the number of times that it regularly goes above, but not for enough time to trip it. So you could get this sort of picture of oh, hang on, this appliance is actually like 4 times now in the last month. It's regularly gone above for a reasonable amount of time, but not tripped yet. And the pattern we see with this is like you see that in the run up to a heater showing a fault. So, so we can basically see the pattern of the heater getting worse over time, and then the trip to say, no, this is an actual safety issue now.
Okay, so that's interesting because it's safety, but it's also a maintenance. It's a little bit like back to your fridges, is that what you're saying is, this is really beginning to use more than it should be, which probably means there's something of an issue. We should look at, maybe changing this or getting it fixed.
Yeah, absolutely. And, and there's places, where this is, more maybe critical, like, so, anywhere where there is a lot of heating that's been electrified, that's going through it, anywhere that's in like a modular building or a portable building, we know that it's not necessarily built, that those buildings are not, necessarily built to be able to sustain the kind of, heat buildup that you might get in, one of these appliances in a regular building, but also places where there's lots of high energy stuff plugged in. So, hospitality is another key one there.
Yeah, so, well, actually, I'm just thinking of some of the events we've done in the past and some of the extension leads which have got lots of plugs in. So I might have to come and borrow some off you. But anyway, now Peter did come back and said pricing model for the smart plugs. Actually, Peter, Adam and I were having a chat beforehand, and it seems it's all on the website. So now that's obviously at a sort of single perspective. If you're looking at a large volume, then you should be going to talk to the guys at Measurable, and I'm sure they'll have a very sensible chat with you. Is that a fair thing to say, Adam?
Yeah, absolutely. Yeah, pricing's all on our, the list pricing's all up on our website. Obviously we do. We've got volume pricing as well, depending on what project you're looking at and what you're looking to do.
Okay, cool.
Yeah.
Right. Now, we did mention behaviour change, but you never really went into it. So
yeah,
I'm going to push you into that one, especially as we've probably only got about 10, 15 minutes left.
Yeah.
So, far away.
Okay. Let's do it. So, yeah, you're spot on with behaviour change in terms of, it's always been a bit of a buzzword. It gets talked about loads. We see cycles of it, coming up. And, we never really wanted to be, one of these companies that then, pushes behavioral change, but it doesn't really do anything, and it's not really, that big. So we have spent quite, a good bit of time, perfecting this with customers. Now, one of the things that we kind of started with was our sockets have got these lights on them, these LED lights, and they can be turned off if people don't want them, if they're out of sight, they're floor boxes behind things. But if they're visible to people, then the LED light shows the carbon intensity API from the grid. So it's directly linked to that carbon intensity API. It shows the mixture of all of the energy that's going into the grid at that given time. So green means that we've got a lot more renewables going into that mix, and red means that we might be using more fossil fuels at that time. But it can also be linked to demand. So high demand times we often see red, and green, and lower demand times we see green. And the idea that we had for it was, if we show this very basic piece of information that is publicly available, anyone can go on to the carbon intensity API and just look at the data. But if it's shown in the context of where you're drawing power from, it could prompt just a quick question, which is, I'm charging my phone, or I want to charge my phone. And it goes between green and red most days. And in some days it stays green all day. And then in winter we get days where it stays red all day. But in those kind of, days where we do see a bit of a change, should I charge my phone when it's red, or could I wait till it's green? We're probably not going to be able to stop using your laptop or, using printers or other things, because everyone's got a job to do. But for the small little bits, like, charging something that's maybe not, not completely essential to you at that moment, you could choose that. So with some of our kind of, deployments, we started sort of onboarding people to this. So I'm going to give you the example of Stink Studio. So they're an office in London.
Whoever came up with the name, fantastic.
Yeah, well, they do some very, very interesting projects with Netflix. They do all sorts of design stuff and video stuff. They've got, they've won a lot of awards for their, their work, and they've got a great office. It's got probably,
and it's not smelly, obviously.
Yeah, that's it. About maybe 150 people or so, in that office. So we went across the entire office space. They've got meeting rooms, they've got editing rooms, they've got kitchen area, they've got some electric heaters, throughout that. From day one, it was very obvious that that Fridays had very low occupancy. So, maybe 3 or 4 people were actually in the office on a Friday, and there was a lot of work from home. So quite early on, we suggested, well, look, the systems can make some quite good savings on a Friday if we turned off, and perhaps occupants could just turn on what they need because there's so few people. And it was met with, no, we cannot deny power to our people working in the office. We've got to have access to everything. We don't want to do that. So we didn't really challenge it. We just said that's fine. Keep it like that. So we went ahead with it. We were still turning stuff off overnight and at weekends. And then we did a bit of an onboarding with some of the occupants and basically showed them what the green light, red light was, how they could make a carbon impact by changing just when they charge their mobile phones. And straight after that onboarding, we saw a 7% drop in carbon emissions. And there was basically no change in energy use. The kilowatts were almost exactly the same. But the emissions had gone down, and it was literally people charging phones at green, rather than red. So that was like a nice kind of small change, not nothing huge, but a small kind of change to it. And a little bit more time went by, and then a group of the occupants reached out to our customer success team and said, "We've noticed that Friday's really, really empty in this building, and we could have everything off, and we'll just turn on the things that we need when we need them." And we said, yeah, that sounds like a pretty good idea, and enacted that. And that was kind of our like where we realized this is the behavioral change bit, where because the socket is now changed, it's something that's in front of them on a daily basis. We originally had tried to change a behavior too quickly. We tried to go straight to, oh, look at all this great savings you could make on a Friday, without stepping. And when it was broken down and it was stepped, and the occupants were in it, and they were on board with it, and they were doing something positive, it came from them without us needing to really do it. And then now that accounted for basically another day's worth of saving, another day where hot water taps aren't having to boil through constantly throughout the day, and meeting room TVs aren't left on, and AV equipment isn't all there in standby or even on.
It's interesting because, and you said there, I can see how you got the emissions, even though it's the same energy usage. Would it be possible to look at? Obviously, you sometimes get time of use tariffs as well, don't you? So if you're using energy at a certain time, it's cheaper than it would be. I mean, I don't know if that's something that can happen through the plugs, or is that more? Or do people just start to think that way because the sockets are sort of almost telling them you should be thinking about this more clearly?
Yeah, you're on exactly the right path there, and this is the groundwork for enabling automatically without having to use prompts. So basically, all of our sockets can integrate with demand side response systems, so they can be lined up to then turn off when energy suppliers are saying that they'll either give you free energy, or they'll pay for certain reductions and things like that. But then that also means that you then have to go and you've got we can identify certain things that can be available for that and automate that, but you also might have lots of things that can't be. And the green light, red light is perfectly lined up to those periods. Red is always going to be in one of those demand periods where the grid wants to reduce, and energy companies want to reduce. And green is always going to be in one of those periods when they want to incentivize people using energy.
Okay.
So if you've naturally already got your occupants incentivizing energy use at green, and trying to reduce during red, you've got them already playing the game for demand side response in the building.
Gotcha. Okay, we're moving on because I look at the time now, and Adam, I think we had one more case study I wanted to go through, which is we've obviously looked at offices and hospitality, etc. Maybe worth down here. Thank you. That'd be really useful.
Yeah, great. This one, look, just to give you kind of a bit of a summary, it's this is an office space. This is quite a decent sized office. It's relatively simple. We've got extension leads on desks. We've got sockets on walls, and from really not that much sort of input, it's a 52% reduction in energy use and a 49% reduction in carbon emissions. And it's really kind of to highlight that this it is not difficult, to get going with this kind of stuff. It's really simple to get to, to install, and the reductions can be even in an office can be quite large.
So I mean, everyone's looking at solar at the moment. It's funny you mentioned about LED. If you're not doing LED, you've got to do LED. And I think most people, I'm sitting in a house where I've had all of my lights switched over to LED, and it definitely made a difference. I mean, I hate to think what the saving was on just the lights, but probably I would have thought 60-70%. And people are looking at solar, etc., and they're capital intensive, but they do have a return on investment. But actually, someone clever said to me once, before you do the solar, get your energy usage down, because then when you do the solar, you maybe not need as much, or you're going to be able to do better. And I think it sort of I get the feeling from what you're doing is actually you're enabling that to happen so much easier.
Yeah, that's it. There's a load of things that you'd like. Solar is a great piece of technology. The cost is coming down. The barrier to entry is becoming lower. But if you haven't done your lights and you haven't optimized that BMS yet, and you've maybe still got all this wasted small power that's being used there, you're going to be speccing it potentially too big. There's adding cost on that. Or the other thing is that you don't have enough space to get in all the panels that are actually needed for it, and you realize that actually we could have optimized first and then done it, and it would have made it a much a much more kind of integrated system where we've now got these systems that are all benefiting each other by being in the building.
Okay, that's brilliant. I'm going to ask if there's any more questions. Please fire them over now. I'll give you a minute or two. Just, I suppose, the final thing. We talked about offices, hospitality. I can really see it from that point of view. Is there places where you sort of think, I don't know, manufacturing or warehouses, or is it anywhere where you can use a plug that this can be used effectively?
Yeah, this is it's essentially, look, we do incredibly well in offices because there are there's not a huge amount more that you can generally do once LED's done, the BMS is optimized. This is the next piece that we can really bring in. We do a lot in hospitality because it's really low capital intensive. It's easy to get going, and we get good visibility of all that energy and the savings very quickly. Paybacks, pretty quick as well. But we go into universities, hospitals. We're in sports stadiums. We're in schools, laboratories, manufacturing sites. Anywhere that has large amounts of appliances plugged in. And probably the only thing we haven't talked about that is worth noting at this stage is, we don't change every plug socket. We don't go after every single plug socket in a building. We are going after the places where there is appliances plugged in that are regularly used by people that are wasting energy. And that makes it really kind of optimized in terms of a payback.
Okay, that's very good. Okay, I've got one more final question then, and I will make this the last question. And I love it. Well done, Kian. But in the stinky studio example, it's actually stink studios, Kian. Was the eventual Friday switch off incorporated into the AI scheduling, or did users decide to do it manually? If it was scheduled, can a user who needs power still override the schedule? That's a great question.
Yeah. So it was an original suggestion by the AI to say, like, this is where you could save a good amount of energy. So all that happened was, we'd said don't do that because they didn't agree to that. When they came back and said it, we just enabled it in there. So it then became part of the system. All of the sockets, every single one that we've got out there has an override button. So if at any point, any time we've got something that's turned off at a point where someone wants to get power, they can always press the button and get power. They can also go into the cloud and also do that remotely as well. But the physical button on the socket itself will always override the smart stuff, as access to power for occupants is like a key part of the offering.
Okay, yeah, that's brilliant. Okay, look, Adam, I'm just going to say thank you very much. You're totally the expert on this, as I've proven by my dumb questions. Some great questions from the audience, though. Just a couple of things. The pricing for this and other case studies are all at Measurable Energy's website, which is measurable.energy. I noticed you put up the thing about the ROI calculator, so that's great. I'm sure if you want to talk to Adam or any of his team, he'll be more than happy to get involved. Oh, sorry, one more question. So well, you did well there, Clement, to get in. How do you measure engagement with the technology during adoption? What do you consider successful? Oh, nice.
Yeah. So from an absolute base point of view, we want to be providing the energy savings that we've said that we're going to provide. So that ROI calculator is one of the things there. We can pre-project what we think the savings will be based on appliances. So we want to be getting those cost savings, the energy savings, the carbon reductions that we're saying, and ultimately that the customer is getting a payback for it, and the payback that we've said that they're going to be getting. That is the absolute core success metric, is that they're getting what we've said they would, the financial payback, and they want to keep going with it because it's getting them those energy savings.
And I'm sure it changes over time anyway, and you're keeping an eye on that from the dashboard and the AI, aren't you?
Absolutely, yeah.
Yeah. Okay. All right, brilliant. I will call it to an end. So thank you very much. If you could please rate this webinar, I'd be very grateful. It just enables us to make sure that we're doing the right thing for you as an audience. Adam, why don't you say goodbye?
Yeah, thank you very much. There's some really, really good questions there. Please, if anyone wants more info, wants to go down a rabbit hole with me, you're more than welcome to reach out.
Oh, there you go. Adam Wright as Alice in Wonderland. That's marvellous. I'm not Alice in Wonderland. I'm Geoff Curren, and I'm going to say goodbye. Goodbye. And by the way, this will be on demand within about 5-10 minutes. So feel free to go back, or if you want to show colleagues, please do. See you later. Bye.